Reduced Order Modeler app lets you interactively create AI-based reduced order models, or ROMs, of subsystems modeled in Simulink. These subsystems can include full-order, high-fidelity, third-party simulation models brought into Simulink as functional mockup units. You can use ROMs for system-level desktop simulation, control design, virtual sensor modeling, hardware-in-the-loop testing, digital twin generation, and design exploration and optimization. Here's the workflow for creating an AI-based ROM. The Reduced Order Modeler app lets you interactively go through this workflow to create ROMs without being an AI expert. In the first step, you can either set up design of experiments and run simulations to generate input-output data, or alternatively, you can import your existing data collected from a high-fidelity simulation model. For the former, the app lets you configure experiments by either replacing or perturbing Simulink model signals using built-in excitation signal types, or by setting block parameters to desired values or sampling them using different methods based on distributions such as uniform and normal. The app also lets you specify which Simulink signals and block parameters to consider as ROM inputs and which signals to consider as ROM outputs. It allows to select excitation signals that are different than ROM input signals. This provides flexibility to configure design of experiments to work for various scenarios. For example, when the subsystem targeted for reduced order modeling is in a closed-loop control and shouldn't be excited directly. You can also specify boundaries for signal and parameter values to define the feasible design space and visualize its coverage. You can then proceed with running simulations with the full order model to collect training data. You can choose to run simulations in parallel to accelerate data collection. Once the simulations are complete, you can view their results before training. As an alternative to performing design of experiments, the app lets you import and use one or more pre-collected datasets from a high-fidelity simulation model to train ROMs. In the next step, using the I/O data, you can train models including cascade correlation, MLP, LSTM networks, nonlinear RX, or neural state space model. The Trial All option lets you use a subset of the collected data to automatically train all available models, helping you select the right model structure to achieve superior performance. The app lets you choose either the full set of inputs and outputs or a subset of them for training. Once training is complete, you can compare the performance of all models to determine which model to explore further. You can then proceed with training the selected model. You can interactively tune hyperparameters and evaluate models sequentially or in parallel with the parallel computing toolbox. Post-training, you can compare candidate models using the accuracy metrics and visualization plots. In the next step, you can export and bring the trained ROM into Simulink for system-level simulation, control design, virtual sensor modeling, hill testing, digital twin generation, and design exploration and optimization. Lastly, you can deploy the trained ROM to embedded hardware using automatic code generation, or export it as an FMU with the Simulink compiler for external use. In summary, you can use the Reduced Order Modeler app to interactively create AI-based ROMs of subsystems modeled in Simulink, including full-order, high-fidelity third-party simulation models brought into Simulink as functional mockup units. Download the Reduced Order Modeler app to get started with creating AI-based ROMs.